All right, so starting at part C, function notation. So just in your booklet, graph of y equals f of x is shown. State the domain and range. So where are we going from domain-wise? -5 and 6, right? So between negative. So how do we state that? So let's go formal on this. So it's the set of all x such that, okay, now what do we say? So -5 is less than or equal to x is less than or equal to 6. Okay, so you always go with the low value is less than or equal to the variable which is less than or equal to the high value. Okay, and we won't put on that x belongs to the rails, we'll just understand, yeah, okay, x belongs to the rails. And what about the range? Set of all y such that, so what's the low? -2 to 3, so -2 is less than or equal to y, which is less than or equal to 3. State each of the following. Some values will be approximate values. So we're not necessarily going to do all of these, right? But there's a PDF of all of the answers online. And there's now a PDF of the examples from the Are You Ready for Calculus? We have crossed off that 30-1. So all of the examples are done, and then Ms. Melcher has put one up where all of the exercises are done, and she's just done that on a separate sheet of paper. Okay. If you find any mistakes, let me know. There might be some, and we'll just fix it up. Okay, so f of -2. What's f of -2? I should make this a bit smaller. Make it a little bit fittier. That's a little better. Okay, f of -2. What's that? What does that mean? So in words, what's f of -2? The value of y when x is equal to -2. And what is the value of y when x is equal to -2? 2. F of 0. So the value of y when x is 0, -2. 5. Or sorry, f of 5. So that's why we don't want to say in words, right? What's the value of y when x is 5? So we say, what's f of 5? What is f of 5? Sure. Okay. No, it says some values will be approximate. F of -6. There isn't one. So we're going to say does not exist, right? Which we will abbreviate. Well, I'll write does not exist. Does not exist, but then we might be saying that more often, so we'll say DNE. Right? Just for does not exist. If f of x equals 3, then what's x? So what is this now saying? If y is 3, what value of x gives you? So you're looking along this line, right? You're saying, well, when y is 3, what's the value of x that gives you that? 4. In the same vein, if f of 4x is equal to 3, then what's x? Well, if x is -2, then you're going to work out f of what? You're going to work out f of -8. So what are we really looking for? We're saying, okay, well, on 3, that means that the value in here, right, it means that 4x has to be equal to what? It's got to be equal to 4, right? The value that I'm evaluating, right? So I want to do, like here, what did you say? You said f of 4 is equal to 3, yeah? So I said, what's the x value when y is 3? And you said it's 4. Okay? What's the, well, that 4x, that needs to be a 4, right? Because when y is 3, I know that this, the input to the function, is 4. So I need 4x to equal 4. What's x? 1. Okay? So if f of x plus 2 is equal to 3, so again, we do the same deal, right? Okay, 3. What does that mean? It means the input to the function has to be the number 4, which means that I need what? X plus 2 to equal 4. So what's x? 2. Okay? You got the same deal here, but I'm not going to give it to you now, because by now you should see the pattern and be able to kind of figure that out. Okay? So I'm going to leave the rest. Well, let's see what else we do there. Let's do this one. If f of x is equal to 0, then what's x? So what you do is you say, all right, I need y to equal 0. Where does that happen? It happens along this line. So if y is 0, what's x? Negative 3. What's x? Negative 1 point. So negative 3, negative 1.4. Yeah, it's approximate, right? What else? 2, like 2, I think it's like closer to 1.9 maybe. What else? Well, you're jumping ahead. What about this? 3.3. And what else? 6. Okay. You will see a slight glitch in the answer key for that particular question, because there's a 14.6 in there. And I said, really? Like, that's out here somewhere, and it's not even on the grid. So it's just a little typo, right? But the rest of these, so they're on the PDF answer sheet that is in Schoology, for which a large number of you have signed up. All right, so you can fill that in, and do these and then check your answers, right? Better to do these and check your answers than it is to just go and fill it in from the sheet. Because you won't be looking at it saying, so what is that? What is that? Which you've now figured out. So what's that? 16. 16, right? Because you say, I need this to be equal to 4. So I need a quarter x to equal 4, so x has to be 16. Then you'll figure that one out. Well, if f of x, so what we have is, whenever we're dealing with functions, we have a function definition, right? We're saying f of x is x squared minus 3x plus 2. That's the instructions, right? So the instructions say, take the input, take whatever is in between the parentheses, and here's what you do with it. You square it. You multiply it by 3, and you subtract it from the value you just got by squaring, and then you add 2. Okay? So in words, this says you take the input, whatever it is, you square it, you subtract 3 times it from that number, and you add 2. So f of negative 3, we take negative 3 quantity squared, right? You're going to put that in brackets. It's the negative 3 that we're squaring. Minus 3 times negative 3 plus 2. So that's going to be 9 plus 9 plus 2, which is 20. So f of negative 3 is 20. Oh, that was a number. What do we do for f of x plus 4? Well, we do the same thing. We say you take the input. The input in this case is x plus 4, and you square it. And then from that, you subtract 3 times the input, and then you add 2. So now, we're not going to get a number, right? We're going to get an expression. Okay, take a moment, work out the expression. I shall also work out, I'll just give you a bit of lead time. And then I will work it out, and then we'll compare. And and you can nod your head or shake your head. Okay, I see nods are preferred. It means I got it right. Shaking head. I'm occasionally going to, on purpose, get stuff wrong. Most of the time I get stuff wrong, it's just I got stuff wrong. Yes?
Can we factor that equation after?
No, never. So simplified form is not factored form.
Oh.
So simplified form, right? Like I want to work this out. So if this was like f of x plus 4 equals 0, then yeah, we'd factor it and we'd solve it. But no. So simplified form, not factored form. If that was written on a diploma and then you went and factored, it'd be like, ooh, we just lost a mark. Okay, and you could do this, and we'll do this. Right? So there's lots of stuff going. Now what's actually happening here is this is a series of transformations. You just don't know what those are. Well, you might be able to look at that and say, oh, I remember back to 20-1 and that, you know, this does this and this does this and that does that. Okay. But what we have is, so I'm just going to sort of do this over here. So I've got -3 times f of x plus 4. We just did f of x plus 4, right? But let's pretend we haven't done that. So what is f of x plus 4? It says, well, you're going to take the x plus 4 and you're going to square it, and you're going to subtract 3 times the x plus 4. You're going to add 2. So there's -3. This is f of x plus 4, yeah? Right? That's what we did here. And then, what do we do in the end? Subtract 5. So you are now looking at -3, f of x plus 4, yeah, minus 5, right? Everybody see that? We got the -3. This is f of x plus 4, right? What did f of x say to do? Square the input, subtract 3 times the input, and add 2. Okay, we know this, so we're going to cheat, right? So we know that this will work out to x squared plus 5x plus 6. So if you were doing this from scratch, you would see a few more lines in here, right? But we worked this out already, so we know it's that, yeah? I mean, you don't be looking at this and going, what magic happened here, right? Like, how all of a sudden did you get from this to this? Okay, well, let's repeat. Okay, now what? Now we multiply by -3. So -3x squared minus 15x minus 18 minus 5. And now we get our final answer. And that's what it's equal to. Okay, any questions on that? If at any point you have any questions, please ask. Okay? All right, so the rest of them you can do, right? I mean, they're all simple variations of this. So 3f of x is just 3 times. So where you see f of x, you're going to replace it with, right? It's a simple replacement. It just says, right, these things are equal. Wherever I see an f of x, I can write x squared minus 3x plus 2. If I see f of 2x, then I know I got to write 2x quantity squared minus 3 times 2x plus 2. All right? If g of x is equal to x plus 3 over 3x minus 5, then determine the simplified form of each of the following, stating non-permissible values. So we have a rational, right? In a rational, there are non-permissible values. Okay? So, what's the non-permissible value for this? So x cannot be equal to 5/3, right? If x is equal to 5/3, we got problems, because we'll be dividing by 0. Now with g of 4, you're not going to have to worry about that, right? If it was g of 5/3, you'd say, we got an issue here, right? Like it's not going to evaluate. So if you did see g of 5/3, you would just write no solution. Doesn't exist, does not exist. You can't do that, so you can't do that. I must pull out one of these days. You can't do that video. But I will. Wait, something. Didn't you see that one? Yeah. Yeah, you guys have seen it. You can't do that. Okay, so function notation is a shorthand, right? Hey, here's the formula. What does it say to do? It says take whatever's in the parentheses and add 3 to it, and stick that over 3 times whatever's in the parentheses, and then subtract 5. So we got 4 plus 3, which is 7, over 7, which is 1. Okay. So that's. What do you do with the 2x minus 1? Well, you're going to end up with another expression with an x in it, right? Okay, so you say, all right, everywhere I see x. So when I do that replacement, I like to put this in parentheses, right? And say, hey, this, that was the x there, right? And that way I don't forget that, oh, that whole quantity is what has to be multiplied by 5, or sorry, by 3. Right? Okay, now we can just simplify this, work it out. So 2x plus 2, 6x minus 8. Do you mind if I just go straight to minus 8? Yeah? Okay. Okay, so here's your answer. Simplified, right? Because everything, there's even, right? Even. So you can factor 2 out of the numerator and a 2 out of the denominator, cancel those 2's. You're left with x plus 1 over 3x minus 4, which means in this case that x may not be equal to 4/3. Okay? If you try and evaluate that, stick an x value of 4/3 in, you got it wrong. Okay, questions? That 3-1 is really just sit down, strap yourself in. It's going to go for 90 minutes. Or in this case, 75, whatever it is. Maybe the shortened form. Most days it's like 90. So I just walk next door and say, we talk too much. So I just spent the entire 3-2 class. Anyway, equations of functions can be written either in terms of f of x or in terms of x. An equation is written in terms of x when the function is easily defined by type. So if we know it's linear, you write it in terms of x, right? 2x plus 3, linear. A quadratic, 3x squared minus 7x plus 12. Nice, easy quadratic, you write it in terms of x. An exponential, 2 to the x. A radical, root of x. The root of 7x minus 2, right? That's easy, that's written in terms of x. And it's important that we know the actual equation. So I'm doing some science, right? A line of best fit. I want an equation. I want to use that as a model to then say, using this as a predictive model, we're going to run out of oxygen on this planet, or whatever. Or, you know, it's probably a ways away. The function could be graphed using a graphing display calculator. I wasn't going to use that, but they keep throwing it in. Using the equation in terms of x, right? So you get the equation, you got y equals the root of 7x minus 2, you can punch that in, you can graph it, you can interpolate, you can extrapolate, right? Find values when x is 17, y is this, and the value of x when y is 92 is this, right? We can answer questions. Now, we also express functions in terms of f of x when the type of function is unknown. So, and we'll look at some examples, or look at some pictures and say, yeah, I don't know, can't really do that. Or knowing the equation is not important. Okay? It doesn't matter that I know the equation, right? What's important is I'm doing some stuff with it. You can't graph it on a calculator or some other graphing program, right? Because you can't punch it in. It's like, I don't know what it is. A function written in terms of f of x is written in function notation. Okay? So that's what we just did, right? You got 3f of x minus 5. Now, but there we knew what f of x was, so we could start with, what was it? Okay? We could start with negative 3f of x plus 4 minus 5. That's written in function notation. If nobody told us what that was, then this is as far as we could go. But they told us what it was, so this is the function in terms of x. This is the function in terms of f of x. This can be graphed. Unless we know what f of x is, this can't be graphed. Circle the equations that are written in terms of x and name the type of function. You can do that. The graphs, they always take the difficult questions in a university textbook and say, the following is left as an exercise for the reader. Right? Which means I can't be bothered spending 3 pages showing you how to do this. So throw it out there. Okay, the graphs of several functions are shown. Some of these graphs could be described with a single equation in terms of x, whereas for some it is not possible. Circle the graphs for which it is bold, not possible. So on diploma, if they're going to use not, you'll usually get bolded, right? It's like, this word is sticking out of you. They want where this is not possible to describe the graph with a single equation. Okay, so should we be circling this graph? No, because what is this graph? Well, we can work it as negative 2. It's like y equals negative 2x plus 3, right? It's a nice linear equation. I can get it in terms of x. I can graph it on my calculator. Punch in y equals negative 2x plus 3. There it is. What's this guy? Well, let's see. Should we circle this? No. Y equals negative. Go run down. So it's negative 1. What do we got? X minus 2 quantity squared plus 4. Okay, there. That's the graph of that. That's the equation for that, right? It's a parabola. It opens down. The vertex is at 2, 4. So there you go. Opens down. Now, how do I know the a value is 1? Go over 1. You go down 1. Go over 2. Going down 4. There's no stretch. Right? Should we circle this? Yes. So I'm going to circle this, right? Like this part here is a cubic, and this part here is linear. So we could describe it as what's called a piecewise function, right? Like we could say, oh, if you're from here to here, it's a cubic, here's the equation. And if you're going from here to here, it's linear, and here's the equation. But you can actually graph piecewise on your calculator too. I think you can set limits. Say, from here to here, I want you to graph this, and from here to here, I want you to graph that. But we cannot do a single function, right? You can't just go on the calculator, punch in one function, and say, oh, it's going to do this. That won't happen. This guy, should we circle this? No. What is that? Absolutely. What's the equation? I think that's the equation. Opens up, vertically stretched by a factor of 3, right? Because if I go 1 from the vertex, in regular absolute value, you should just be going up 1, right? So here, but I'm going up 1, 2, 3. So that's a vertical stretch factor by a factor of 3. Left 1, down 4. Right. Pretty soon you're going to look like, you might be looking at this going, what? I remember that, or we never did that. You're going to look at that in another week and just go, oh, yeah, vertically stretched by a factor of 3, horizontally translated left 1, and vertically translated down 4. At least I hope you will. That's the goal. Should we circle this one? Yeah. It's like, really? Yeah, come on. Like it's a constant function, then it's linear, then it's a different linear, then it's another constant function. Okay. So we could define it with 4 different functions, right? We could say x is negative 1 as long as x is less than or equal to negative 2, right? X is whatever the slope of that line, when it's between negative 2 and negative 1. X is when it's, but you cannot put this one function into your calculator and say graph and get that. Okay, what about this guy? Yeah, don't circle it. It's radical. So it's radical. It's not as easy to recognize a radical as far as stretch factor and stuff. So I'm not going to write an equation for that. I don't know if I can. Let me look on here and see if somebody wrote an equation. So it's not radical. It's rational. Rational. Okay, and that is the equation for it. Maybe. It says next to it, maybe. Right. Like, I knew the x minus 2. I knew that it was shifted right too, but it's that stretch of, yeah, okay, maybe. 9. If f of x is x squared, then write each of the following in terms of the function f. So for example, 2, x plus 4 quantity squared minus 5 can be expressed in terms of f. So remember, we want to write this as f of x instead of x squared. Okay? We want to write it in the form where you won't be able to graph it, but you'll be able to look at it, not now, but a little bit later, you'll be able to look at it and say, oh, these are the transformations I did to this function. So what are we going to write for x minus 3 quantity squared? So we want to take x squared and we want to make it x minus 3 squared. So f of x is x squared, right? So what are we going to write? So if x squared becomes x minus 3 quantity squared, what's f of x become? f of x minus 3. No, just f of x minus 3. Not x minus 3 squared, right? Because the f of x says, take whatever's in the parentheses and do what? Square it. So what do I want to do? I want to take x squared and have it become, we're starting with x squared. I want that to be x minus 3 squared. But f of x already is x squared. So then we just go f of x minus 3. And what's that going to give us? X minus 3 quantity squared. That's what we want. 7x squared minus 2. So I want to take x squared and I want it to become 7x squared minus 2. So what's another way to say x squared? No, f of x. So you look up there, f of x is x squared. Wherever I see an x squared, I can write f of x. So my f of x is going to become what? 7. Okay, what's 7f of x? 7x squared. What else do I need? Minus 2. Okay, try the next one. So the combination of the two above, right? So start off by saying, what do I want to become? I want x squared to become negative x plus 1 squared plus 4. So I want f of x to become what goes in the parentheses? X plus 1. And then, are we done? What do we need? Plus 4. Right? So what we're doing is converting from an x squared, which is a function that we could graph, into some general function notation, and just saying, okay, well, you're going to go negative f of x plus 1. What's f of x plus 1? It's x plus 1 quantity squared. Oh, okay, that gives me the negative x plus 1 squared, which I need. And then, oh, I need a plus 4. So we got to put a plus 4. 16x squared. So I want x squared to become 16x squared. So now it says there's more than one way. So what's one way? 16f of x. Right? Just 16 times f of x squared. What's another way? F of 4x. Okay, so you're wondering, well, how'd you get that? Well, what's f of 4x? You got to take that, make it 4x, and square it. What do you get? 16x squared. So that works with a quadratic. It won't work with a cubic or something like that, right? It works with a quadratic because there's that symmetry and that. We'll talk about it as we get into the transformations. So this is really two different transformations, right? We just don't know what names to put with them yet. Okay, but we will. And then we'll be able to look at it and say, oh, that's or this is like this is one thing, this is another thing. But they both give the same result. You can't tell them apart, right? Because they're the same thing. This is 16 times x squared, and this becomes 16x squared. If h of x is 3 over x, then write the following in terms of the function h. All right, so let's just do the first one. So start with the original, just in terms of x, right? Start with the in terms of x. So if it's in terms of x, I want 3 over x to become 3 over x minus 5. Okay, I've got the original function, this is what I want it to become. Well, how do I do that? I just subtract 5 from the original function, right? Well, in f of x notation, h of x notation, what are we going to call the original function? It's h of x. So what do we do to h of x? h of x minus 5. Yeah. Just take the original function and subtract 5 from it. Okay, we'll try the next one. So you're going to start with, okay, I'm starting with 3 over x, and I'm ending with 3 over x minus 2. So h of x becomes h of x minus 2, right? So, I mean, really, you're just looking at this and you're saying, oh, the x was replaced by an x minus 2, so let's replace the x with an x minus 2. But now I've got 6 over x plus 5. All right, well, we kind of know how to handle the plus 5, right? So I'm going to do something, and then I'm just going to add 5 to it. Okay, so 3 over x becomes 6 over x plus 5. Now, there's a couple of ways to do this, right? So what's one way?
2h of x.
Yeah, so 2 times h of x, right? So 2 times 3 over x is going to be 6 over x. So 2 times h of x. So we start with h of x. We go 2 times. Am I right? 2 times h of x. Okay, now what's 2 times h of x give me? 6 over x. And what do I need now? Plus 5. Here's another way to do it. You can look at this a little bit different. So you say 3 over x becomes 3 over x over 2 plus 5. Why would you do that, right? The first one was pretty easy, right? You just had to multiply by 2 on this. 3 over x over 2 becomes 3 times 2 over x becomes 6 over x, right? So this is 6 over x. Okay? But in function notation, then, it says, so h of x becomes h of what?
Negative h of x.
So this needs to become this, right? So your input becomes, it's not an x now, what is it? It's an x over 2. What's h of x over 2? It's 3 over x over 2. What's 3 over x over 2? That's 6 over x. So we've got the 6 over x dealt with. Now what? Now we add 5. And again, what's happening here is there's 2 separate but equal transformations on this particular function. Right? Like there's 2 ways to get this, but we don't know the words to go with it yet. We will in the next couple of days, right? We could say, oh, you're doing, in this case, really, this is a vertical stretch by a factor of 2 and up 5, and that's a horizontal stretch by a factor of 2 and then up 5. So, okay, we just don't know that yet. And then I'll leave the negative 3 over 2x for you, and there's 2 ways to do this as well. Okay, so 2 possibilities. Okay, and try them before you just go look at the answer, right? How do you know the answer is right? Well, put an x over 2 in there, then simplify that and get the 6 over x plus 5. Right? Put an x minus 2 in the original, you get 3 over x minus 2. Right? So like try to get back to the original. If what I've written is correct, then this should take me back to, like I should be able to get the 6 over x plus 5. The graph of y equals x squared is transformed, resulting in the graph of y equals negative 3, x plus 5 quantity squared plus 12. You did this last year, right? You did these quadratics. Okay, so go find your notes, do this year. Okay, so you can do this. Algebraic, determine the x and y intercepts of the function. You can do that. Should we start on it? Okay, well, what kind of function is this? Well, it's a quadratic function, right? Where's the vertex? Negative 5, 12. what's the order for these transformations? I'm not sure. What order should you go in? So vertical stretch, then reflection, and then translation. Okay, so do you stretch, reflection? Oh, hell, let's just do it. Okay, so what's going on? Number one, what's the first transformation here? So you said it's a vertical stretch by a factor of 3. So write it out in words, okay? Because the words are your friend. If you're going to go graph this thing, you'll say, okay, I need to take this point and do this to it. I need to vertically stretch it by a factor of 3. Then what do I do? Reflection where? In the x-axis. Followed by, so a horizontal translation, right? We're actually going to use the words. If it comes down to I don't have much space to do things, vertical stretch becomes VS. Horizontal translation becomes HT. But if we have words, write out the words. You have room. So it's a horizontal translation. How much, which way? Or which way, how much?
5 units left.
Okay, so 5 units left. And you could also say left 5 units. Okay, I don't really care. But if you say horizontal translation, it must be followed by the word left or the word right and a number. Or it must be followed by a number and then the word left and the word right. Okay, and last one is vertical translation. Up 12. So up 12 units. So you could say up 12 units or you could say 12 units up. But both of those must be there, right? Which way, how much, or how much, which way. You can't just say vertical translation 12, right? What? Can't say horizontal translation 5. The point negative 2, 4 lies on the graph y equals x squared. Determine, which means what? Show your work, okay? So you're not going to see the word determine on the diploma exam because you cannot show work, right? However, you should do all of your work in the booklet. Like show all your work, do all the work in the booklet in case something happens to your scan form or something. Then they have the booklet that they can look at and mark.
So the diploma's all multiple choice.
No, there's 28 multiple choice and 12 numerical response. The diploma is all machine scored. And if the machine doesn't score your form correctly, having all of the answers in the booklet is a backup they can go to. Right? If something happens to your form and you left half the answers in the booklet blank because you were just doing them and then putting the answer down, it's like, well, we could look at it, but what do you want us to do with it? Half of it's blank. We cannot give you credit for stuff we can't see. So do the entire exam in the booklet. When you are done the entire exam, check it over. When you're done checking it over, do it again, take a look at the time, and when there's 5 minutes left, then sit down and fill in the bubble sheet. Or like when you've gone through it and you're happy with it, then fill in the bubble sheet, right? Because that way you won't have to do any erasing. It won't be like, oh, I was checking over and that shouldn't be an A, it should be a C, and now I've got to erase that. And there's this big smudge, and, oh, no, I tore the paper. And it's like, can I have another one? No, because your name is on there and it's got a sticker on there, right? Don't worry, it's whatever. It's thunder. Okay, oops, negative 2, 4. So here's how we're going to do a mapping, right? One step at a time, following the words. Okay, so the word is there is a vertical stretch by a factor of 3. So I'm going to say VS by 3. So what negative 2, 4 becomes what? If it's vertically stretched by 3, the point negative 2, 4 becomes negative 2, 12. Starting with negative 2, 12. And we are doing reflection in x-axis. So negative 2, 12 becomes 2, 12? Or does it become negative 2, negative 12? Or does it become 2, negative 12? Or does it be? There's 4 possibilities. What's the right one? Can you give me the right one? Negative 2, negative 12. Okay, so the y value, so it was up here, right? It was at negative 2, 12, got reflected, it's now at negative 2, negative 12. So now we are starting with negative 2, negative 12, and we want to do an HT5 left. So where are we now? So if you move it left 5, where are you at? Negative 7, negative 12. And now we will do the final transformation, which is a VT up 12. And where do we end up? Negative 7, 0. Okay, find lots of room there. Sometimes I'll just string them along in a line and just say this to this, then put this arrow and go to here, and then put this arrow. Like not redo the points. I'll just say negative 2, 4 because negative 2, 12 becomes this, becomes this, becomes this. Okay, this is a little more detailed.
Could we do the reflection? Would that still work?
Would it make a difference?
Yeah.
So negative 2, 4 would become negative 2, negative 4. Would become negative 2, negative 12. So, yeah, it could. Okay. In this case. Okay. So generally we want to stick with the order of stretch, reflect. And the reason is we don't only do vertical stretches, we're also going to do horizontal stretches. Okay. And in that case, things might go off.
Okay,
So stick to the order, yeah, unless told otherwise. Stretch, reflect, translate. Okay. Do all of your stretches, whatever they are. Right? There are 2 possible stretches, vertical, horizontal. Do all of your reflections. There are 3 possible reflections. Right? You've only done 1. So there's vertical, there's horizontal, and there's in the line y equals x. Okay. Do all of the reflections. And there are only 2 possible translations, horizontal and vertical. Okay? But there's more going on, so if you stick to that order, right? Because if you reflect and then stretch, but there's a double reflection going on, or there's a reflection in another line, then no, right? All bets are off at that point. You're not getting the same thing that you were doing. Okay, so we got negative 7, 0. Oh, and you can check that, right? So you could say, what is y equal to? Negative 7. Okay, wait a sec. What am I checking that? We'll verify. So we start with we have the equation negative 3x plus 5 squared plus 12, and we're trying to verify that for negative 7, 0, right? So we're going to put negative 7, 0. Yeah. What? Wait. Hang on, I'm on the wrong. There we go. Yeah, okay. So y is equal to negative 3, x is negative 7 plus 5 squared plus 12, which is negative 3. We get negative 2 squared plus 12, so that's negative 12 plus 12. So y is equal to 0, and that checks, right? So if you put a negative 7 into the transformed equation, it does come out as the point negative 7 for x and 0 for y. Okay? So that verifies. That's a way to check. Is it really negative 7, 0? Well, if I throw negative 7 into the transformed equation, I do get a 0. Sorry, I was looking at D while I was trying to algebraically determine the x and y intercepts of the transformed function. Verify with the graphing display calculator. Okay, so I'll let you do that, right? It's just for the x-intercept, what do? Set y equal to 0, and for the y-intercept, you set x equal to 0, right? And you're using that equation, y equals negative 3x plus 5 quantity squared plus 12. Okay, so you do those. And verify that with the calculator. Sketch the graph of the transform function, labeling the vertices and intercepts. Okay, so you can do that as well. Number 12. Graph of y equals x squared is transformed, resulting in the graph y equals 1/4 x squared minus 6. Drive the transformation to the correct order that were performed on the graph of y equals x squared. Okay, it's like 11, so you can do that, right? Point negative 2, 4 is like 11, you can do that. Algebraic determine the exact values x and y intercepts, you can do that. Okay, 13. Thus far, we've used set builder notation to describe the domain and range. So the domain is the set of all x such that x belongs to the real. Set of all x such that x is less than 2. Set of all y such that y is between 5 and 7. Range is a set of all y such that y is less than or equal to 2 or y is greater than or equal to 5. We can also use, and will use, interval notation. Much better than domain. Look, this is all you're writing. No set of, and no such that, and no belongs to the real. So here's interval notation. Comparison between both is shown. Note, in this case, when the domain is expressed in interval notation, it looks exactly like notation used for coordinates of a point. Therefore, it's important to be aware of the context regarding the notation to determine whether you're referring to a domain or a point. Right? So when you write domain 2 comma bracket 2 comma 5 bracket, that some people look at that and say, that's 0.25. No. That's a domain. We're expressing a domain. So here's how it works. If it's including the interval, if it's including the 2, you use a square bracket to say it includes the 2. So this says the domain goes from 2 to 5, including the 2 and including the 5. So that's this guy. This says the domain goes from 2 to 5, but it doesn't include, so then we use round brackets. So a square bracket says includes, that you'd use when you had less than or equal to, and a round bracket is excluding the 2, right? So from 2 to 5, but not including 2 nor 5. This is 2 and to 5, but includes the 5. Doesn't include the 2, round bracket, comma, includes the 5, square bracket. For all real numbers, now there is no negative infinity to include, so for all real numbers we use round brackets, right? Or parentheses. So it's from negative infinity to infinity. You're saying it goes from negative infinity to infinity. Those aren't numbers. You can't say, yeah, it includes infinity. No. So we use parentheses. Y is less than or equal to 2, so from negative infinity to 2. Strictly less than, round bracket. Less than or equal to, square bracket. Infinities, always a round bracket with the infinities. Okay, so you do infinity, so make a note of that somewhere. Anytime I'm doing infinity, it's got a round bracket. Okay, I cannot do a square bracket with infinity. And lastly, or. So you use this U, and the U is for putting together. Okay, it's actually the union of sets. It's used for a union of sets. And union is combining together into one thing. Okay, so this says, so it's got an infinity, so it's a round bracket. So it says from negative infinity to 2, including the 2, and, or, so the union is the word or it's from 5 up to infinity, and it includes the 5, right? If that was an open bracket here, that would be just greater than 5, not including the 5. So this is interval notation. Right? So if you're using infinities, you have round brackets. Otherwise, if you're using numbers, a round bracket indicates that you would, in the original, be seeing a strictly less than, or strictly greater than, and a square bracket indicates you would be seeing a less than or equal to, greater than or equal to. Okay? And anytime you have infinity, brackets.
So what is the infinity replacing? Like, so replacing the y, or?
Well, this says y belongs to reals. Can have all values.
Okay.
This says it goes from negative infinity to positive infinity, which is all values.
Yeah.
This says it goes anything greater than 5, so it's from 5 to infinity.
Okay.
With a round bracket, because anytime you're doing infinity, you must have a round bracket. You cannot have a square bracket. Right? Square bracket includes, it means it goes up to there and then it stops.
So it's like all the positive infinities that are created.
Well, this is positive. So anything greater than 5 up to positive infinity. This is anything from negative infinity up to 2, which means that it's just less than or equal to 2. Okay, less than or equal to 2. So if you want to translate, this says less than or equal to 2 or greater than or equal to 5. It just says it more concisely and without words. Okay, and it'll always be a union. So put these two, this or it can't be both, right? Because you can't belong to both sets. If you're in this set, like number 3 or 4 aren't in here, right? Or anything between 2 points or 1 and 4.999 is not in there. Okay, so if you say, hey, is 3 part of the range? No. 3.7? No. 2.6? No. 2.1? No. 2? Yeah. 1.99? Yeah. Anything below 2. Anything greater than 5. Anything below or including 2. Anything above or greater than. Anything 5 or above. Okay. So if these guys were strictly greater than strictly less than, these would be round brackets as well. Okay. Do that just for you to summarize what was just said, right? Symbol U represents union or combination.
I just had a question about the interval notation.
Sure.
You know, it says the square bracket 2, 5.
Yeah.
How would you know if that is saying that it's greater or less than 2 or smaller or equal?
So this includes the 2. It's between 2, but it includes the 2. And it's up to 5, and it includes the 5.
But I mean, how would you know that it says it's greater than 2?
Greater than 2? It says any number between 2 and 5, including the 2 and including the 5. So 2.1, 2.2, 3, 4, 5.1, no.
But I mean, when it says that it's bigger than 2,
It does say it's bigger than 2.
or smaller than 2, how would you know?
How would you know it's small? This is smaller than 2. This is any number smaller than 2. And including 2. Goes left to right. Yeah. So it's just same as say, when we say 2 is less than or equal to x is less than or always equal to 5, we always go low value to high value.
If it's smaller, it's going to be
Interval notation is low value to high value. Yeah, so if it can go down to any low value, that's negative infinity. So anytime you see a less than or equal to 2, you know you're going to see a negative infinity, comma 2. Anytime you see a negative infinity or positive infinity, you must use a round bracket. Okay? You'll get used to this. It's much easier. Right? Much better. And we're going to use the heck out of it in calculus, so because it's way easier than saying that. Right? Okay, this just and then tells you here. Okay, that's just for you to kind of fill in to summarize that. And then here, just some practice. So practice these, then go in and check the answers, right? And it's not a big deal if you mess this up initially, and as long as you've got it figured out by the end, you go, I see what I did wrong, and now I see why that's the right answer. Okay? So try these. I mean, should we do one of them? Here, let's do this. X is greater than or equal to 5. Do I start with a round bracket or a square bracket? Square bracket. Round or square? Which one? Square. What goes here? There you go. Okay, so you're going low to high, you're going left to right. I'm going from 5 to infinity. Are you including the 5? I got a square bracket, I'm including the 5. If that was strictly greater than 5, round bracket with the 5 saying do not include the 5, but anything above. And anytime you've got an infinity, so this guy here, you got 1 square bracket, 1 round bracket. Okay, and numbers have here, you cannot write 11, comma 4. That's not true. You can write 11, comma 4. It's meaningless. Okay. And then some of these are, here's interval notation translated back into, and do the formal stuff here. Okay, you demand the set of all x such that, blah, blah, blah. Complete the following table for the quadratic function described by y equals negative 3x plus 5 quantity squared plus 12. What's the domain for a quadratic? What values of x can you have? Anything. Or what values of x can't you have? Well, I don't know. I can put anything in for quadratic. So in set builder, how does that work? Okay. And for the other one, you have a little bit more work to do. Not much. It's pretty easy to figure out. But you don't have to do a lot of work for that. Whichever notation set builder was used in a question to describe the domain and range, you must be consistent and use the same notation in your work for that question. So if we give you a question, it lists in set builder, you must answer in set builder. Okay, so if we say the domain for this is this, what's the range? You got to give it in set builder. If we give it an interval, you got to give it an interval. On the exam, you'll see both, so you have to be able to use both. Translate back and forth. That is. Oh, okay. So now you can take some time and just work on some things we didn't do. Check those over. I think if you look at your timeline, I don't think there's any homework for today, is there?
Why would you want it?
Okay, so let me just add a little bit of work for you.